Hello. In this math video, I will do a GED math video regarding comparing different functions. Okay. So there isn't there aren't any notes for this section because we covered it a lot from the previous sections. So it's a little bit of a mixture of those notes from the previous section. So let's just start on. Let's just start with question one. So question one, here we have a table, and then on the we have the time column and the distance column. So number one says Kim runs a 5 kilometer race in 25 minutes. Sarah runs according to the table. So okay, I see. So Tom runs a kilometer race in 25 minutes. Sarah runs according to table. So this is Sarah's table. So at zero distance, it's zero time, that makes sense. So it takes for Sarah to run 1 kilometer, it would take her 5 hours. And for Sarah to run 2 kilometers, it would take 10 hours. And then for Sarah to run 3 kilometers, it would take her 15 hours, right? So which one who runs faster on average? So does Tom run faster on average? Uh so Tom runs 5 kilometers in 25 minutes. So let's figure out how do you find the average? So average speed is in kilometers per hour. That is equal to total distance over total time per hour. So let's start with Tom. So Tom, what is Tom's average speed? So Tom's average speed is, so he runs 5 kilometers. So distance is 5 kilometers for 25 minutes. If you reduce that, that's going to be 1 out of 5. And then let's do Sarah's. So Sarah's average is, so what you could do is you could pick any time you want. You could do 2 out of 10, right? Yeah, you could do any time. It would be 3 kilometers and then for 3 kilometers, it would take her 15 hours. So 3 out of 15 can be reduced by 3. So that would be 1/5. So it looks like they're the same, 1/5 and 1/5. So I don't think it's A. I don't think it's B. I think it's C. Tom and Sarah runs at an average speed rate. Okay. Okay, so that was question one. Let's move on to question two. Okay, question two says two cars are racing on a straight track. Carla's car tra Carla's car travels according to the function d equals 3t, where the rate is measured in kilometers per minute. Charlie's car travels according to the graph. So this is like question one. So yeah, it's very similar to question one. So we have two people, Carla and Charlie. This is Charlie's graph. And Carla uh is equal to distance equals 3 times t. Okay, so what are they asking? They're asking which car travels faster? So if did you know that 3 times c, so did you know 3 is like your rate? Yes, so distance is equal to rate times time. So the rate is 3 or 3 over 1. And yeah, so Carla's average speed is 3 kilometers per minute. So is 3 kilometers per minute. And then Charles, so this is where, so we know that distance equals rate times time. And uh, we want to know the rate. So what you got to do is isolate R before we plug in any value. So this is for Charlie. So solve for R. So I'm going to divide both sides by T. So I get R equals D over T. And then what you got to do is find, pick a point. It doesn't matter which one. Yeah, so R is so we have to pick a distance. So if you use this point, do you see this point right here? You can use any other point, but if you use that point, what would be the distance? So distance is on the Y and then time is on the X. So distance is going to be 15 and then my time is going to be 6. So wait, let me double check. So actually it should be, but you could do pick any point. So if you do, for example, if you did 10 distance, so it would be for Charlie, the distance, if you choose 10 kilometers, what would be the time? It would be at 4, right? So you look at this table and then you're going to be 4 over time. And if you, that simplifies as 10 divided by 4 is 2.5. Wait, hold on. I think I did a little bit. Yeah, I messed up right here. Oh man, it's so easy to make a mistake. So let me recap. So we know that Carla drives at a distance of 3 equals t. Now, if you recall, distance is r times t. So they tell us that d equals 3 times t. So that automatically means that the rate for Carla is 3 kilometers per minute. Okay. So this is Carla's average speed. So Carla average speed is 3 kilometers per minute. And then let's do Charlie. So Charlie, we kind of have to figure this out. So we know that distance is rate times time, and we got to you can either isolate R first or you can plug in a value. So if you look at the table, if you chose let's see. If you do 15, if you do 15 kilometers, so at 15 kilometers, it would be at a time at 4 minutes. So if you plug that back value into this, so that would be, or you could solve for R. So if you solve for R, you would have to divide both sides by T. So you get R equals distance over time. So we said that at 15 kilometers, it would be at 4 minutes. And that is going to be 3.75. So for this, Charlie's rate is 3.75 kilometers per minute. So it looks like it's going to be Charlie's car travels the fastest. Okay, let me check oh, this is still question two. So yeah, that was question two. Let's move on to question three. So question three, we have a table, right? I mean, a graph, a linear graph, and we need to know which, consider the function A and B below. Function A, that's function A, it's a linear line that's going positive. And then function B gives you a table or coordinates. Which of the following is true? The slope of function A is greater than function B, or Roman numeral 2, the slope of function A is less than function B. So how do you find the slope? So if they don't give you the slope, like if they give you coordinates or even if they give you coordinates or even a graph, what we have, you could have to use this formula, m equals y2 minus y1 over x2 minus x1, right? So let's look at let's try to find the slope A for slope A. So what you got to do is you got to pick two random points. Be any random point you choose. As long as it's exact. So if I chose this point, for example, 2 comma 4, and then another random point would be like 0 comma negative 2. And then if I do x1, y1, x2, y2, what would be my slope? My slope is going to be, if you uh, put in the formula, it would be negative 2 minus y1, which is 4. And then x2 is 0 minus x1 is 2. And then negative 2 minus 4 is negative 6. 0 minus 2 is negative 2, and that is positive 3. So the slope for graph A gives you a slope of positive 3 or 3 over 1. Okay, now let's go find slope B. So they actually, in function B, they don't give you graph, they give you tables or points. So go ahead and pick any point you like. It doesn't matter. So if I use the first one, -9, comma -22, and then the other one, I'll use 6, comma 6, right? So x1, y1, x2, y2. So formula is y2, which is 6, minus y1. So y1, so it's minus a minus 22. And then x2 is 6 minus a minus 9. So over here, two negatives becomes a positive. So with 6 plus 22, 28. And then on the bottom, two negatives becomes a positive. So 6 plus 9 is 15. And then if you do 20, if you put it as a, you could put it as a decimal, 28 over 15 comes out as 1.86. So you could do it as a decimal or you can reduce it, try to reduce it. It's perfectly fine. I'm just going to leave it as a decimal because I need to know which one is larger. So this has a slope. So function B has a slope of 1.866. And then function A has a slope of 3. So obviously function A is the greatest. Okay, so it would be Roman numeral letter A. Okay, let's check our work. Perfect. Okay, we got a perfect score. Okay, so I'm going to stop here. I think this would be the last, these will be like the last practice exercise. Now you're going to do some actual practice exams. So, if you need to review any of these practice exercise before we do an actual practice exam, go ahead. So, yeah, I'm going to stop here.